Greetings of the day. Today I would like to present on the said topic with the objective to showcase the utility of using a biphasic media for dissolution study of albumin-based injectable nanoparticles. To set the context, I am trying to repurpose pioglitazone for the treatment of cancer. Now pioglitazone, being a BCS class 2 drug, is practically insoluble in water, but it does show high affinity to human serum albumin. With these two characteristics in mind, I tried to develop a formulation so that it can improve the solubility of pioglitazone in vivo and also can deliver the drug to targeted sites. The formulated formulation was albumin-bound nanoparticles of pioglitazone, which caters to both of these characteristics and also shows an advantage of being eligible for a biowaiver. The rationale behind getting a biowaiver for these albumin-based nanoparticles is that the albumin-bound nanoparticles, once injected in vivo, undergoes dissociation to its naked albumin state, with the drug still bounded to the albumin. These kind of formulation thereby acts like an immediate release dosage form, making it eligible for a biowaiver. These kind of studies can be done in vitro with the help of DLS technique, whereby the dissociation can be studied through the dissociation kinetics. This is an acceptable technique for the European Medical Agency, and Teva already received a biowaiver for their product Pazinir, which is a generic version of albumin-bound paclitaxel nanoparticles. Although it is accepted by the European Medical Agency, it is still not accepted by other regulatory agencies, including US FDA, PMDA, and VISA. These regulatory agencies prefer a more conventional dissolution study to understand the release profile of the drug. Accordingly, multiple researchers all across globe are trying to study the release profile, but the current available research work suggests a sustained release of this kind of formulations, which is contrary to the behavior that is observed in vivo. Thereby lies the need for a non-conventional methodology for the study of these types of formulations. US FDA in their CDER report of financial year 2022 released and mentioned about a study whereby the US FDA researchers are using a biphasic media for dissolution study of the commercially available paclitaxel-bound nanoparticles. The researchers used 1-octanol as the organic phase in order to improve the sink condition and thereby facilitating the drug release in the dissolution media. The volume of dissolution media used for this study was 900 ml. A similar concept was used in our lab to study the pioglitazone albumin-bound nanoparticles. The lyophilized albumin nanoparticles was first reconstituted with 20 ml of water to get the reconstituted suspension. From this reconstituted suspension, 2 ml was transferred to a 2 cm snakeskin tubing dialysis membrane, which was then clipped and transferred to the respective dissolution medias. These dissolution medias then were subjected to 300 rpm stirring and set at a temperature of 37 degrees Celsius. At predetermined time intervals, a 2 ml sample was taken from these dissolution medias, and this study was continued for a period of 2 hours. The samples taken were next analyzed using a UV spectroscopy at a lambda max of 260 nanometer, which corresponds to the lambda max of pioglitazone. The assay values or the absorbance from taken from the absorbance values were next mapped, and the release profile of the drug in respective media was obtained. As observed, there were a number of dissolution medias which were studied, the first one being the 0.9% sodium chloride solution at a neutral pH, which showed a very poor release for the drug from the formulation. We also implemented the surfactant-based dissolution media, whereby 0.2% volume by volume 2-in-80 was added to the sodium chloride solution, but we got a release of less than 18%. Next, we also tried to study the US FDA researchers proposed dissolution media of 1:1 organic versus aqueous solution, where the organic phase was 1 octanol. Even for this case, although we see a higher release percentage, but it was somewhere below 30%. So actually it's also not giving us a favorable result in terms of having a immediate release. So we also tried to check whether we can use any other organic solvents as part of the biphasic media. We selected methanol, which is used regularly as a mobile phase for pioglitazone. It is also approved in the USP monograph. So we also utilized this solvent for our study. We did see a higher release percentage compared to the other 3 dissolution medias, including the one proposed by the US FDA researchers, but it was way below the permissible limit of 80%, which can be considered as the limit for immediate release dosage forms. Then we further studied with other dissolution medias, one of them being organic phase with a mixture of 4:1 part of methanol to acetone. The rationale behind selection of this mixture of organic solvent was a study conducted by Tao et al., whereby through thermodynamic correlation and also through practical approach, we obtained that at a ratio when the methanol and acetone is mixed in the ratio of 4:1, we will get a higher solubility for pioglitazone. The same rationale was used, and when we did our study, we did get a completely 100% release within a period of 15 to 20%. This kind of behavior can be attributed to the highest sink condition provided by the organic phase, or can be attributed to the higher sink condition provided by the biphasic media. If we go to the more basics of this study, the reason why we are seeing this higher release is can be attributed to the release kinetics. For a free drug, the rate limiting factor is the permeation rate provided by the dialysis membrane. But for a bounded drug, it is the release kinetics which plays a bigger role. The release kinetics for a bounded drug is the one that determines how much drug will be freely available in the donor phase, so that for it to pass to the receiver phase. And also the release kinetic is influenced by the solubility of the drug in a particular dissolution media. By enhancing the dissolution profile, or by enhancing the solubility of the drug in a particular dissolution media, we are thereby improving the release kinetics, and thereby we are seeing a higher release pattern, as we have seen in the case whereby we are using a biphasic media where the organic phase contains 4:1 parts of methanol to acetone. The complementary studies like that of in vitro dissociation kinetics and also the in vivo pharmacokinetic data generated in Vista rats also comply with the data that we have seen with the in vitro dissolution study. For the final outcome, we can say the current dissolution method that was developed was able to capture the immediate release profile of the said drug formulations in vitro. The highest sink conditions ensured by the biphasic media displayed its utility in dissolution method development for such kind of formulation. Also, the simplified setup and the simple method of measurement ensures reproducibility and robustness, and thereby can be used as an effective quality control tool for similar nanoformulations. As far as IV-IVC is concerned, the current method needs further justification for it to be accepted as an IV-IVC tool, but this method can serve as an orthogonal study for already accepted dissociation kinetic study. That's all from my end. Looking forward to answer if there be any queries from the esteemed panel members. Thank you.